Can everybody hear me okay? Up in the back, you good? Okay, we're gonna get going. Okay, so if everybody can sit down, quiet down, we're gonna get going. Welcome back. I hope the 231 quiz went well. Did it go well? How went the quiz? Okay, seems mixed opinions. Okay, so we're gonna talk today about how to code effectively in a team. Okay, so please quiet down if you're still talking. Okay, so most of your work as an engineer is going to be in a team, and that definitely includes developing software. So what do we want? We want parallel development. We want multiple team members to get things done at once without getting each other's way, without wasting work, without blocking each other. Okay, and this is harder than it sounds. So has anybody heard of this book? This is a famous book about software engineering called The Mythical Man Month. It's reasonably old, it's from the 1970s, but it's considered a classic. Who's heard of this book? Anybody heard of this? Okay, so it's written by Fred Brooks, who was in charge of a very large software project, basically writing a complete rewrite and the release of a new mainframe operating system for IBM in the 1970s. It's a very major project. IBM was dominant in technology at the time, and these are kind of make or break products. And the project was late. And as it became clear it was going to be late, his superiors, who would be at the absolute top of the company, would say, okay, well, how many more person months is this going to take? And we'll just give you more people. We'll put more programs on this. We need this faster. So, he would give answers, and his managers would give answers about, well, we need another 300 person months. Okay, fine, we're going to put another 30 people on this, and therefore it's going to go faster. And what he found is that the more people they put on this project, the slower it went. So it didn't actually make it deliver faster, it made it deliver slower. It's actually been shown multiple times. So this is a maxim that's actually known as Brooks's law, that adding manpower to a late software project makes it later. Okay, why does that happen? That's very counterintuitive. Doesn't happen if you're trying to build a house. Doesn't happen if you're trying to shovel your driveway. It happens because you have all this communication. You have people who have to get up to speed on how the software works. They have to communicate because it's a very collaborative activity. If you add new people who do not know what's going on late in the project, you're already behind, they actually slow down the people who already know what's going on, and the project gets even slower. So it's hard to speed up software projects that are late. And we need to look carefully for these techniques by which we can have multiple people working together and the whole is greater than the sum of its parts. Like we actually make, or is better than one person doing it. We actually make forward progress. Okay, so how do we do that? Okay, so I'm gonna give you a couple minutes. Talk with your teammates or your table mates about this. How are you gonna do this in this project? Starting with milestone 1. You're a team of 3, how are you going to break things up so that you work efficiently, you don't get in each other's way? Okay, so let's take a couple minutes and think about that. what should you do? Okay, so E05. What do you think? How are you going to attack this?
If you keep in constant communication with your team so they know where you're at, it makes working together a lot more smooth.
Okay, so one thing is a lot of communication, and that is going to help. Like that mythical man month, a big part of the problem was people getting in each other's way, right? Doing things that were breaking each other's code. So communicate a lot. Any other ideas? Okay, so I'm going to write this down. So. Anything else? Is it just talk to each other a lot, work together a lot? Is that all? Definitely a good idea, but is there anything else you should be doing? So you're starting milestone 1. Will you each just go into the lab and just start coding? Or are you going to do anything else before that? Okay, so C06, what are you going to do? Where are you? Okay, C06, what are you going to do? What, that was an accident? Okay, but. Okay, and you know how to turn the mic off, so you did it. So I won't call you anymore because you passed the mic test. C12, what do you think?
I think it's also very good to early on establish.
I'm just going to turn you up a bit. Get a bit closer to the mic if you can. Speak really loudly. Your mic seems quiet.
I think it's really good to establish some ground rules at first.
So it's really good to establish
some ground rules.
Some ground rules of how you're going to work? Yeah, that's a good idea. What would one of those ground rules be?
Maybe like choosing a coding, like a coding style, like maybe.
Okay, so that's a good idea. Choose a coding style. So maybe this is a good thing to do up front. Talk about how the code should fit together, what the style should be, rather than after the fact.
Yeah.
Makes sense? Let's go to E05. E05, what do you guys think?
I think another really important thing is when you're doing commits, have very detailed messages. I guess that goes with communication. Have very detailed messages for what you add to the code. Also, making sure that every team member has a very good fundamental understanding of what you need to do with the code so that you can distribute the work evenly so that everyone is clear on what each other is doing and where, I guess, who needs to use other people's functions, stuff like that.
Okay, so you said a lot of good ideas there. Clear commit messages so you can see what everybody's doing, and then before they do it, make sure everybody has a good understanding of how you're distributing the work, and do that up front. Okay, so that's a key planning exercise for every one of your milestones. Work out who's doing what. You can adjust it, right? Agile means this is not a suicide pact. You make a plan of who's going to do what. Certain things fall behind. Certain things are harder than expected. You can change it. But you do need to make some quick plan. Okay, so you're going to distribute the work evenly up front. Any other thoughts? So C10. What do you think? Where is C10? Yeah, go ahead.
I think having very good comments is also key, and meeting oftenly, because everybody needs to know what's going on for integration, because if everybody is not on board, when it comes to integration, you're going to have a lot of issues. If everybody knows what's going on and how you want it to all end up, that one common goal, it's going to be easy to integrate, especially with milestone 1, where you have a lot of functions that depend on others.
Okay, so you said a bunch of good things, so good comments. We're going to talk about code style in another lecture, but basically, yeah, code is much harder to read than you think. So you need to comment well so your teammates can understand it. You can even understand it a few weeks later. You also said make sure you got a shared goal. Makes sense. Any last thoughts? So C12, anything else you're gonna do to try to be productive as a team?
Yeah, have in-person meetings. Yeah,
right.
Those are much better than like Zoom meetings.
Yeah, that's a good idea. A lot of problems get solved by just being near each other. You're more agile, you build that trust faster, all good ideas. So one other thing that I guess I'll mention here, so we talked about distributing the workload evenly and up front. That's a very good idea, and you're going to come back and see if it's still even. Maybe some things are harder than you thought. You also want to minimize coupling. Okay, so that's a key idea of, as you distribute your workload, try to do it in a way where milestone 1, for example, there are multiple functions. You can give some functions to different people, and some functions look kind of related. So those you should probably give to the same person. You're not, and let me ask you, yeah, okay, so let me just go through some of my ideas on this. So you want to have this work distribution conversation like now, if you haven't had it. You're going to discuss the functions as a team. It probably does not make sense to say these two people will write one function, because it's too fine-grained. You're going to be writing code on top of each other. Probably much more logical to say one person is writing each function, split it across all the 3 members. Estimate how hard these functions are, right? You don't want to wind up giving the first 5 functions to the first person and the second 5 to the second person if those are very different in difficulty. Think about which ones are closely related, so one person is going to be more productive at doing both of these. I've seen teams in the past sometimes say, okay, this person will write a certain function, and then this person will write the code in load map, loading a data structure to make that function fast. Do you think that's a good idea? No, it's not a good idea. The reason it's not a good idea is you've very closely coupled those 2 people. So that's not a good idea unless this is the absolute last task you have left. There's really nothing else you can do in parallel. Otherwise, why wouldn't you say, one person takes a certain function, passes both functionality and performance, another person takes a different one. They're fundamentally less coupled. To be agile, it is perfectly fine to say, well, we don't know how hard all these functions are. I know we're trying to estimate difficulty, but we don't have a good sense. So you know what, let's just pick the first 2/3. We'll divide those up. The last third, we'll get to them later. But we better get these first 2/3 done sooner, with maybe a week to spare. So we set an earlier milestone. We'll see how those ones went, and we'll see who, maybe somebody's not done, somebody else is done early. We can farm out that additional work to the person who's done early. So that's agile, right? You have a work queue, and you can grab things from the work queue. So you don't have to divide all the work up if you don't want to. Okay, so I said one of the things you want to do is try to split up functionality. So if you work in different files, that's great. So you might want to use more than one file in your program, but Git's pretty good at merging things together as long as you're working in different parts of the file. So you can keep them in fewer files. But if you divide up the features so you're not writing the same code, as you write this, basically I can have Tony Stark writing one thing in one file, Bruce Wayne writing another function in a different file. They're each building, they're testing. When they pass the tests, they commit the code, they push it back to the main repo, and it's going to be pretty easy to integrate, right? One of them's going to push first, the other one's going to have to pull that code and integrate it, but because it's in different files, solving different functions, the integration should be easy. It's unlikely to have any Git conflicts, so it should be nice. No wasted work. And you repeat this over and over again. A problem that teams get into all the time in this course is because they're not used to working with other programmers, they don't integrate often enough. They just kind of go off and say, I'll write my code, and the last day we'll put it all together. That is a recipe for a really stressful last day. So what you want to do is, each of Tony Stark and Bruce Wayne here have finished one function. They test it, it works, they commit it, they put it back. They pull, they both now have the updated code. So they're constantly integrating their changes together as soon as they work. Okay, now you can't make all the features totally independent. You might have some helper functions that more than one person wants to use. So in that case, you need closer communication. There's some common code here now that both Bruce Wayne and Tony Stark are modifying. There's a higher probability that they get conflicts in that code, right? They could both change the same line of code. So when you have to have 2 people working on some common functionality, try to get that common functionality done earlier, because there's more chance for dependencies, things that need it, more chance for conflicts. Integrate even more often. Even more important, you make a change to that, you push it back right away, you tell your teammates to pull it. Okay, so yeah, there's a word for this, continuous integration. And it's considered best practice. And it appears to be against human nature, right? So my own grad students, they tend to want to go off on their projects and work for too long without integrating their code back. So you have to fight that tendency. They sort of assume that integration will just happen easily, and often it doesn't. So just integrate small bits of code back whenever you can, but don't break the build. Okay, so I just talked about this. Integration is hard to predict how long it'll take, so do it in little pieces all along. One reason, obviously, is you don't leave it to the end when it's a huge schedule risk. Another reason is it actually makes it easier to move tasks between team members. So let's say milestone 1, some functions take longer than a person expects. But that person has basically kind of written some functions, not written others. The code is kind of half broken, but some of it's working. And he's never put anything back in the remote repo. And now you're getting near the deadline, so you're saying, well, I can help out, right? Like, I'll take over some of those functions. And, but he's saying, well, I got them half done, but I got other stuff that's, I got some stuff working, some stuff broken, but it's all together. I can't put it back right now. It's really hard to move tasks around now because you have a bunch of code that is only on one team member's disk, and it may not be in a state to share because the person is trying to do too many things at once. So don't do that, right? Get a little bit of code, get a function working, push it back to the remote repo. Okay, but you don't want to break the build. So don't interpret this as I wrote 3 lines of code, they don't compile, but I don't care, I'm just putting it back in the remote repo. Okay, that is destructive because your teammates, once they pull, they can't work anymore, right? Like, they can't actually build the code. So you do not want to commit broken code. Now, what does broken code mean? It means it won't compile, or it breaks previously working tests. Now, there may be tests that never worked that still don't work. That's fine. Nobody, that just wasn't written yet. You haven't made anything any worse. But don't make the world worse. And won't compile is kind of the worst of all. But breaking existing tests is also bad. Now, let's say I have a whole bunch of code on my machine. It's not fully working, but I want to get it back so my teammates can see it. You can comment it out, right? So you can have the code, but it's commented out or it's deactivated somehow, like with an if statement. And now they can see it, and they can help you work on it, but it's not going to break the build, because they'll have to turn it on before they work on it. Okay, so that's one way to work. Partition up the work, but reintegrate often. Another way you can be productive is to split development and test. So we can have one person. I got Tony Stark's developing new features, and maybe he's behind, so he needs help. So Bruce Wayne is testing and debugging some of these features with him. Test and debug is massively parallel. If you have some bugs in your program, you can actually have a lot of people trying to work on different bugs, even on the same bug, because most of debugging is trying to figure out what's going on. So this is the one place where you can add many people, even late in a project, and still get productivity gains. So that's something that you can exploit. Okay, the last thing is pair programming. Who's heard of pair programming? Okay, so a few people. Anybody want to describe for me what pair programming is? Let's see, C06, you know it? I'm going to call on you, see if you can describe what is pair programming. Whoops, I think I turned on C05, so I suddenly did a lateral to somebody else. Let me get rid of that. Somehow? Ah, okay. Okay, I think I finally turned you on.
Is it 2 people working at the same computer taking turns programming?
Yeah, so pair programming is 2 people working on the same computer. What do you think? Is this a good idea? Or is this just a way for U of T to save computers, right? We'll have 2 students per computer, maybe next year 3, who knows?
I think it can be good if the people respect the time of the other one, and maybe they can help point out issues that they might have overlooked quickly. But I think also you could get in the way of somebody else if you're too overbearing, I guess.
Okay, so yes, you said you think it could be productive, right? Because one person's helping the other, seeing maybe mistakes that he or she is not seeing. And yeah, that's actually what various studies have found, that this is actually a productive thing to do. So particularly if you've got maybe some complicated things to take care of, 2 people working on it on the same computer is not a bad idea. They're typically given these names, driver. So the driver's actually got the keyboard, is writing code, and that person is basically focusing on the details. And the other person is the navigator. The navigator's reading the code, giving feedback. Wait a sec, did you think of this corner case? What if no street name matches that, etc. The driver probably gets tired faster because he or she is actually writing the code, so it's best practice to kind of switch roles frequently. Don't say, I'm at the keyboard for the next 3 hours and you're giving advice as the navigator. Switch back and forth. We also in this course tell you that one of the things we're looking for evidence of contribution and distributing tasks well across the team is git commits by everybody. So if you, and every year we'll have some students who say, well, I was pair programming, I have no commits, but Bob made all my commits. Don't do that. We're telling you the best practice is to switch frequently, so you should both have some commits. When you switch, actually go to another computer or log out and in so another person is actually making the commits. So it's pretty intuitive, how would you do this? But if you want to, this website has a tutorial on how would you do pair programming. Okay, so is this a good idea? Like, is this more productive or not? So there are studies on this. What they find is with pair programming, there is less code written. You'll get more code written if you give two people two computers and they go off and work on different things. But the code that is written is of higher quality. You spend a large fraction of your time as a programmer debugging. So basically, there are the mistakes that the driver, the person coding, would make. There are mistakes that the navigator, the person seeing more of the big picture and watching for errors, would make. And what makes it into the code is now actually just the intersection between those, which is smaller. So you get fewer bugs, you get higher quality code. It does other benefits. Okay, you're in a new team. You don't know how you work together. You're solving new problems. This helps the team become more cohesive because you're forcing a lot of communication. It grows the expertise of your team members. So by doing this, you're sharing knowledge, and you each become better. And it helps team members read each other's code. So you're trying to learn what code do you write, how do you comment so that people can understand it. And coding in this way with two people rapidly teaches you that. I can write this and I think I know what I meant, but the navigator has no idea what I'm doing. So maybe I have to change my variable names, maybe I have to change my structure, use more functions, and maybe then it's more understandable. Okay, so most studies on this say that it is actually more productive to do pair programming for new teams because of these benefits where the team's getting more cohesive, people are sharing knowledge, there's mentoring, or if one programmer is not an expert. So then the person is learning, being mentored by the expert. Once teams know things well, you have fairly senior programmers, then you can do some pair programming, but programming more independently becomes more productive. So it's some of each. Okay, so as you're working in a team, you're going to have some conflict, some issues sometimes. So let's talk about that. Okay, in a common one, I told you don't break the build, right? So don't put back code that doesn't compile or breaks tests that used to work. But it's going to happen that the build gets broken. Probably, and this happens to most teams. Okay, so Professor Chong and I are in a team, and I come in, I pull the latest code, I build it, and it doesn't work. So I send him this email, because this is work. This is a problem. I can't do my work while the software is in this state. So what do you think? I'm going to give you a minute. Think about this email that I've sent. And being able to send good emails is actually a very important skill. You're going to find in your career, it's not just at school, in your career, you send a lot of emails to people, and a lot of instant messages and so on, asking them to do things. So how you communicate by email matters. So I want you to take a minute, think about what are the pluses and minuses of this. So let me bring up a timer again. It's a short email, so I'm not going to give you very long. But talk about with your teammates of, is this a good way to communicate this? If not, what would you do to improve it? What do you think? Okay, so looks like F04, I don't know if you turned this on accidentally, it looks like you have an idea, I'm going to call on you. What do you think of this? Where is F04? Still learning the, yeah, there we go.
As somebody trying to debug this, I have no idea how the code has been changed, right? I have no idea like what might have broken the build. Like, essentially, I just don't have enough details to know to diagnose the problem, really.
Yeah, good point. So this is a really bad bug report. Something is broken, I'm not telling you what. Okay? So it's not very specific. It's going to make it hard for me to reproduce it. Any other issues with this? What do you think? So I heard some good ideas from A12. A12, how about if I call on you guys? Because I know you have good ideas on this. So what do you think? What do you not like on it?
I think generally it's just too vague. You don't know, you know, like there's no detail as to what's being broken, how long, you know, how important it is, or you know, just generally like there's not enough information that you can work off of.
Yeah, so it's again vague about what's really broken, but he also pointed out some other vaguenesses. Vagueness. Is this a big problem? Is there a specific time by which I need this? Also, you know, Alan might go, well, maybe this isn't my problem. I didn't really give any evidence of why this would be his problem. So it's not good. So it's not very specific. Haven't really told Alan why I think it's his problem. Haven't said if it's a big problem he needs to jump on right away or what he needs to do. So it's pretty terrible communication. Okay, so let's go on to this one. Okay, so look at this for a few seconds. Sarah's our third team member. Okay, so Alan, once again, you broke the build. Sarah and I can't work. This is unacceptable. Fix it now. So what do you think? I'm just going to call on. You can buzz in right now if you have some thoughts on this communication. It's good? Somebody must have an opinion. Okay, A09, I see you reaching out. I think you have an idea. You like it?
Like the other one, it's not specific enough, saying like what's wrong and like when they should reach out. But also like it kind of, like it's more emotionally charged than it needed to be.
Yeah, okay, so it's still not very specific. It says you broke the build, doesn't give evidence. And it has, I mean, on the plus side, it does convey urgency. Okay, and it says what I want, fix it now. And it says it's, you know, I can't work. On the other hand, you know, this tone, email, okay, so people at the back, can I get you guys to quiet down? It's hard to talk over you. All right, thank you. So you have to be really careful about tone in an email. Email has no, you can't see the person. So emails come across typically as colder than they actually are. So I wouldn't want to send an email like this because it comes across as condescending, angry, and that's just going to damage the relationship within the team. And it's not, why am I doing that? That's not going to achieve anything. Even if I do actually feel angry, I should not write an email like that. And if I didn't feel angry, then I just wrote a sloppy email. It's not a good idea. Okay, how about this one? So this is a longer email. Hi, Alan, there are many compilation errors in streets.cpp. Last commit was last night. We think it's your code. It's holding Sarah and I up. Sarah and me up. Can't compile. Please take a look as soon as you can and let us know when you can fix it. If it can't be fixed in the next hour, we're going to have to revert your changes. Okay, so what do you guys think about this? Anybody want to weigh in? Good, bad? What do you think? Okay, so C10. Looks like you have an opinion. What do you think?
I feel like it's better than the previous response since it kind of illustrates what's going on, and it's more softer in tone.
Yeah, so I agree. So it's got a bunch of positives, right? What is the evidence? What do I need you to do? When do I need you to do it by? Doesn't have that emotional tone. So Made to Stick said, you know, emotion helps people remember things. That's true. So sometimes you want that. You're giving your presentation about your big achievement. You want people to have some emotion to remember it. It also works in a negative way, though. Somebody gets an email that's really annoying. They actually remember it for a long time, and you don't want them to remember it. They remember, I hate that guy, right? That Betz, I hate him. I hope that this project fails. I don't want that. I'm not trying to convince Professor Chong to remember he hates me. So, any other thoughts on this one? So I think E05. What do you think?
I think that the actual message is a lot better than before, as our colleague said. And I think that if I were to receive this message, it would be perfect. I know exactly what would happen if I haven't done it yet. It tells me what time I have to do it, and it gives me a lot of background information on what's happened, especially with how this file was, the last commit was at 8 p.m. I know what time it was last committed. The information that I have, I feel like is enough to work on it.
Yeah, so it makes sense. I mean, even the fact that we're saying which file and what commit, Alan can immediately start working on, we've been given pointers to the bug. It's probably here, but we don't know what to do. So Professor Chong, what do you think? Let me find your buzzer. Where are you here? Your G06? Any thoughts on this one?
I think it looks pretty good. Again, as the student just said, I have a very clear idea of what I need to look at, and in particular, how pressing the issue is and how much time I have to fix it, and what will happen if I don't fix it in that time.
Okay, makes sense. One of my former head TAs, I'd be sending emails out to, people we're doing research with, people in this course, and he was impressed at how I would think of various ways a person could misinterpret an email and try to write it to avoid that. And that came from working at Altera for many years. We're asking many people very quickly to do things. You kind of think, how can I make this very clear so they know exactly what I'm trying to do? So it is a useful skill. You will use it in your career. So yeah, this highlights basically what people have already talked about. I think there is something though. People are busy. Okay, people are busy, they get distracted. So Made to Stick points out you can bury the lead. Like, it's important to get your most important information across first, because you can lose somebody's attention quickly, and they might even just decide not to read the rest. So maybe we could put this in the title of the email or the subject line, but it's only down here that we say, this is a broken build that's holding us up. And probably that should have come in the very first sentence, just to basically get across the key information right away, assuming that Professor Chong is very busy, and we want to get his attention right away. Okay, so you can have other conflicts. These ones are just like a technical, somebody broke the build. We could have a partner who's not meeting commitments. What are we going to do in that case? So, and this is going to happen at some point in your career for sure. It might happen in this course. So I want you to take a minute and think about, if a person's not meeting their commitments, what are you going to do? It's, again, a really important skill. You go to industry, they expect you to be able to handle this because it will happen. Okay, anybody want to weigh in on this one? So buzz in if you've got a thought on what you'll do. Okay, so here's my solution. Okay, so Professor Chong and I are working together. he feels I'm not meeting my commitments, so he emails the chair of the department to tell her that I'm not meeting my commitments, right? So what do you think? Is that the best possible thing he could do, or is there anything he could do that's better? So C10, what do you think? What would you do? What do you think of the strategy that I just said Professor Chong would have? Mail the chair of the department. I don't think he'll really have this strategy, but let's say he did that.
I would say that would be very harsh to begin with. Again, it would damage the relationship with your teammate, right? I would say, like, instead of doing that, it would be much better to just talk with your teammate about it, like, why is he not meeting the deadlines? Because, for example, he could be weak at time management, so you could give him tips on time management. And if that doesn't work, and if he has harder functions supposedly that are with high speed requirements, he could consult his teammates to ask for advice and maybe follow the pair programming where if his teammates are free, they can help out as well. And yeah, pretty much that's it.
Yeah, good idea. So you said talk to the person. This sounds really obvious, but every year, Professor Chong and I will each get multiple emails from teams saying, Bob has been driving me nuts all semester. He's done nothing. I can't take it anymore. I want all his marks, and I want him out of my team, and please don't tell him I said this. And we don't want people to do that, right? Talk to Bob first, right? Talk to Bob when the first problems arise. You can escalate it to us, that's appropriate, if things aren't getting better. But there shouldn't be, I haven't said anything all semester, and now I want to essentially go nuclear right away. So you said don't do that, talk to the person. Talk in person. Okay, I said email tends to be a conflict enhancer. It's no emotional content. When you know you have, there's a potential conflict here, have an in-person meeting, better than email. Any other thoughts on this one? Okay, so I'm going to go to Professor Chong. I kind of gave him, I made him the stand-in for sort of not a very good strategy. Let's get some better strategies from him. So, Professor Chong, anything you would add to this?
I would say there's been a lot of talk about missing deadlines and then people finding out about missed deadlines when they go to work. I think that with good communication, you should know that your partner or your group member is not going to meet a headline ahead of time, and you should be able to develop a strategy to figure out when that deadline is going to be met and how to actually kind of revise your strategy before it actually becomes a problem.
Yeah, that makes a lot of sense. So you said basically, make sure you got deadlines, you're tracking those deadlines, you're seeing, I've got a concern about how well this person's going to do, let's make sure we're going to get some advance notice. I had to do this in industry. So if a person is not meeting his or her commitments, I would manage that person gradually more closely, right? More specific deadlines. You should always have specific deadline, but they get more specific, more of them, and you're tracking them closer. So you're having these frequent conversations, and they're concrete. You know, you had this deadline, it was Tuesday, now it's Thursday, it's not done, what's going on? So yeah, all good ideas. So I wrote a few of these down, okay? So I already mentioned that. Again, this meeting where you're talking about there's some conflict, you're trying to be factual, not emotional. This is not a case where you're trying to use emotion so the person remembers. You're trying to bring down the emotion so they don't remember the conflict. You try to get to the solution. You will probably have to talk multiple times. You know, maybe it was just a miscommunication, it goes away, but it's pretty common that if there's a pattern of a person doesn't meet his or her commitments, that continues for some time. That's okay, right? That's part of the process. If you have to be a bit patient, you go, I may have to talk multiple times, employ multiple strategies. Write down the outcome on the wiki, right? That's how you're tracking those deadlines and those that Professor Chong talked about. Don't just have a verbal agreement, you're going to get this done by Tuesday. Write it down so everybody agrees on what the commitment is. Should you talk to your TA or CI? You definitely should. Your TA and CI are like your management. They should be brought into this conversation if the conflict is persisting. It doesn't mean it's irresolvable, it's just you're not hiding it. But you always want to tell your teammate first, because you're trying to resolve it. That's how adults behave, right? When you're a child, you just tell your parents to make your brother or sister do what you want. Eventually you figure out that doesn't work anymore. It doesn't work in industry either. So you try to resolve it. But if it's not resolved, you don't hide it. You write it down on the wiki, and you start discussing it, the whole team and the TA. And if the other teammate actually won't show up, which would be an extreme case of not meeting commitments, well, then you talk with the TA about that as well. Okay, does that make sense? All right, so that's it for conflict, and now we're on to something a bit more, get a little more technical about testing. So the philosophy that you should have in your whole engineering career is if you didn't test it, it doesn't work. So you assume all code is broken until proven otherwise, because usually it is, and this is a safer assumption. You also want to have the mindset of you look at what a program does, not what it's supposed to do. So we talked in the debugging tutorial this week about how you're a detective. You're trying to find bugs by forming hypotheses, checking them, and gradually getting to the root cause. Okay, so it sounds obvious. Think about what your program does, not what it's supposed to do, but I've had a huge number of conversations over the years with students who will tell me, my program does this. And I say, but you say it doesn't work. And they go, well, yeah, it doesn't work, but this is what it does. They're telling me what it's supposed to do. And they need to get out of that mindset and say, when I do this, the program does that. Now, I want it to do this other thing, but it doesn't. So have that mindset. You want to think, with testing, you want to kind of think of how could anything make it through my tests? So as you're writing your code, you're thinking, what are all the cases that might occur? Try to cover them. And then as you make your tests, you're trying to make all the corner cases and weird combinations you can think of to see, did you cover them all? Okay, when do you test? So some people try to make tests at the very end of a project. It's not a great strategy. You want to develop tests as you code, or even better, before you code. That's called test-driven development. Now, it can be hard to write tests before you write the code, because you might not quite know how to make the tests, but that is a good practice if you can. Otherwise, make sure you're making them together. It fits in with the agile development, right? You've got your idea, you build your prototype, you test it, you refine it, you repeat. Well, you can't test and evaluate if you didn't make tests. So you've got to make them as a key part of developing the software. In test-driven development, the tests are the detailed specification. So what do I mean by that? It means that you don't write, I mean, you do have documents, we write them in this course, of what are you supposed to do in your various milestones, or header files say how the APIs work, so you still have documentation, but instead of making the documentation extremely long, laying out every possible case, and expecting people to read it really, really carefully, you rely on the tests to give you a lot of the detailed specification. They can still actually read the tests, so they are a form of spec. And the key thing is they can be executed. You can run these tests and see if the software actually meets the specification. Okay, so there are different kinds of tests. So there are end-to-end tests. And this is probably what you've used in your programs to date. End-to-end tests means you send in input from a user, or input that is just like what a user would type. Maybe you capture it in a file and you send it in. And then you get output, which is exactly what you would give an end user, and you make sure it matches what you'd expect. So it tests the whole program. There's a different kind of test called unit tests, and we're using a bunch of them in this course. And what a unit test does is it tests small pieces of a system. So it could be a single class, single function, could be a group of them, but it tests smaller units of functionality. Okay, so what do you think, if you've got any thoughts on this, buzz in. What do you think the strengths and weaknesses of these two kinds of tests are? And you should have some of both. So these both exist, they exist for a reason. But what are the strengths of system tests and what are their weaknesses? So if you've got an idea, hit your microphone and I'll call on you. Okay, so C12. Thank you. What do you think? Where are you, C12? Okay, there you are.
So for unit tests, you can make sure everything works, and then putting it together should be a lot simpler. I guess that's the whole idea. And for systems tests, benefit would be that you only care about what the user ends up seeing.
Okay, so the unit test can test your components, and then no matter how you put them together, they should work. That's the idea, I think. So maybe a deeper level of testing. And then system tests basically only test what the user does, which you could consider a strength if you're not testing weird stuff that a user will never do. But it can be obviously harder to have deeper tests.
Yeah.
how do we know we covered all user input and we never checked any of the internals? Okay, so only test what a real user could do. Yeah, so those are good points. Let's see, E05, any thoughts?
If there's a bug in the output, testing with system tests can obscure what's going on under the hood. So you might not know what's going on, and it might be a little difficult to debug with system tests.
Yeah, that's a key advantage of unit tests. If I have a system test that fails, okay, I sent in this input, I got this output that's wrong, the cause could be anywhere in the program. So my debugging, I should use what we talked about in the tutorial this week, a wolf fence method to try to figure out where is this bug coming from, because like whole program, I can't read that. You know, the last program that I was architecting when I was in industry, Cordis, was 11 million lines of code. Okay, so you can imagine if I go on a bug, I'll just sit down and I'll read all 11 million lines of code and see if I can find it by code inspection. That's going to be hard. So a key advantage of unit tests is because they're testing a small amount of functionality. If they fail, it's obvious where to go look, right? It's in the class or the function or the set of functions that you're testing. So those are excellent points. So I'm going to erase this and talk about what my thoughts were. So yeah, the advantage of system tests are they test the whole system. That's important because you can have gaps otherwise, right? What if this function plus this function plus this function all called in this way? Each of them works individually, but when you put them together this way, it doesn't do what you expected. So you got to have some system tests. But they are hard to debug because the problem could be anywhere. And they also can be fragile. Fragile means I send in some user input and I get this exact output. I might change my program a little bit and my expected output changes. Okay, that breaks my test, but it's not a real bug. It's actually a problem in the test. I don't want to spend all my time updating tests, so I actually prefer not to have these fragile tests. But I need to have some of them. And unit tests is basically what I just said. Okay, so they're easier to debug. They can be less fragile. You write them in code. They don't break as often if you do them well. But they don't test the whole system, so you need some system level tests because otherwise there could be gaps. Okay, so there's another, this is a continuum.